studying arc length. So essentially what happens is, let's say we have a function like that. Let's say this is y equals f of x, and you want to know over some interval from say a to b. That's what the a to b in this. You want to know how long this curve is. So if you're to take, so in other words, if you take this curve and you're to stretch that out into a, let's say you turn that into a string, and then you stretch the string straight, then you want to know how long it is. That's what arc length is, or that's the idea behind it. Okay, so this is the formula right here. Now you know that, so what happens is, let's say this is our original point, and let's say we want to estimate this distance here. Okay, so the idea is that you're going to estimate it with this line segment. Now the line segment is set up like this. Okay, so this is your dx, the change in x. This is your change in y, and so this hypotenuse is what you're looking at. So this is the square root of the change in x squared plus the change in y squared. Okay. Now, if you divide everything, or not divide it, what you can do is, well, you multiply this by dx over dx. Like that. And so sort of what happens is, as this dx, this dx in the numerator goes in to the radical as dx squared. Okay, and so you get, I'm sorry, the wrong one. I chose the wrong one. I don't know what I'm thinking. This one in the denominator goes in as dx squared. Okay, and under the radical. Okay, so you have this 1 over dx squared times dx squared plus dy squared, and that's all times dx. And then as you distribute that in, you get 1 plus dy dx squared dx. Okay, and so that's why you get something like this as what you're integrating from a to b. Okay, that's kind of where that comes from. We can go into more detail about that, but yeah, that's kind of where that goes from. Okay, and then this formula here is for the situation where you have a function x equals g of y, okay, and you're going from c to d. Okay, that's what this formula here is for, okay, for this kind of situation. Okay, so if you have a y equals f of x, going from a to b, and x, then it's this one, and c to d, this is y values going from c to d, then, and you have the x equals g of y, then then you use this formula here. Okay. So let's get to the homework exercises. Generally, in practice, these integrals are really hard, and even if you like put what you think is an easy kind of function, then usually when you put it into here, it becomes very complicated to integrate. It's like really hard to integrate. Okay, so anyways, number 1, use the arc length formula to find the length of the curve described by y equals the square root of 2 minus x squared from 0 to 1. Okay, so y equals 2 minus x squared to the 1/2. So the first step is you want to find dy dx, which will be what we're going to put in to the integral. Okay, so that's, you bring a 1/2 down. This is reduced by 1, so 1/2 minus 1 is negative 1/2, and then a negative 2x comes out right there. Okay, so these 2's will cancel, and you're going to have a negative x, and then the denominator is, it's going to be over 2 minus, the square root of 2 minus x squared. Okay. That's our dy dx, or our f prime of x, if you will. Now, the formula from the previous page, let me copy that down here really quickly. The formula is you're integrating from a to b of the square root of 1 plus f prime of x squared. Okay, and so you need to calculate f prime of x squared, and that's going to be x squared over 2 minus x squared. So I squared the numerator, just get x squared. Square the denominator, just get sort of the radical. Okay, so, and then we plug it into here. Of course, a and b are 0 and 1 from here. So a is 0 and b is 1, because these are in x. And then you have the square root of 1 plus this. Dx. Okay, now that looks really hard to integrate, but what you can do is get a common denominator first. So this 1 turns to 2 minus x squared over 2 minus x squared. So that's the 1. And then of course you have this plus x squared right there. So that's really nice. These are going to cancel. So 2 over 2 minus x squared dx. Okay, now this calls for a trigonometric substitution, and I think that x equals the square root of 2 sine x, or sine theta would be the best one, because when you put it in here, it's going to become, this will become 2 sine cosine theta. Okay, so that means that x squared is 2 sine squared theta, and it also means that dx is the square root of 2 cosine theta. Okay, so we plug everything in. We'll get the limits of integration in a minute. That's 2 minus 2 sine squared theta. And then the dx is root 2 cosine theta. Let's go ahead and change the limits of integration as well. So we have 0 and 1, or let me put the 1 on the top and 0 on the bottom. Okay, so when x is 1, then let's see, we have 1 equals root 2 sine theta. So that means that sine theta is 1 over root 2, which means that theta is going to be pi over 4. Okay, so the 1 is the pi over 4. And then when x is 0, we have 0 equals root 2 sine theta. And so that means sine theta is 0, which means theta is 0. Okay, so there was 0 right there. So 0 to the power of 4 of this. And let's see here. The denominator becomes 2 cosine squared, but it's going to be root 2. When you take the square root, you're going to get root 2 cosine theta. Oh, I forgot the d theta. Forgot the d theta there too. And wow, this is really nice, because at this point, the the cosine thetas cancel out. One of those root 2's cancel out. And you just have root 2 d theta. And so when you take the integral, you're just going to get root 2 times the length of this, which is pi over 4. So root 2 pi over 4. And that is, that's going to be the answer. Now it says also check your answer by noting that the curve is part of a circle. Geez, I haven't really left myself very much space for that. Let's try, let's see if this is enough space. So that we're checking to, because the actual problem says check that, note that it's part of a circle. So if we square both sides of this, okay, so square both sides, it gives us y squared equals 2 minus x squared. And then bring the x squared over, so that's a circle with center 0, 0, and radius square root of 2. And if you look at what's going on, essentially what happens is you're integrating from where, as you're going from, when x is 0, y is root 2, so you're up here. And when x is 1, y is 1, so you're right here. Okay, and so you're looking for how that part of the circle right there, or you can think of it in terms of pizza. That's a slice of pizza right there. Okay, so that's the round part right there. That round part is part of the bigger circle that goes around like that. Okay, so you just want to know how long this is. And do you know that the length of an arc is equal to the radius times the angle, times the subtended angle? Okay, that's this distance. That's this distance here. Okay, so this distance is the radius of the circle times the angle times this angle here. Okay, and this angle is pi over 4. The radius is root 2. Okay, and so we get the same answer as here. Okay, so that's kind of verifying it. And it would have been much easier to do this, of course. But then we wouldn't be using this glorious formula. Oh, well. Okay, any questions about that up to this point? I will point out that it's very easy to make a mistake when you're doing this and then end up with something that's pretty much impossible to integrate or that's wrong. Okay, number 2, set up an integral that represents the length of this curve, x equals the square root of y minus 5y, from 1 to 4, and use technology to find the length correct to 4 decimal places. Okay. So, I mean, this is pretty easy to integrate, to differentiate, right? But when you plug it into here, this is going to be really hard to integrate. So we're going to use the G formula, the second formula, this one right here, because the limits are in y. Okay, so the limits are going to be this and this. So that means that there's going to be a 4 right there that goes into the formula right here. This part right here is going to be the square root of 1 plus g prime of y squared dy. Okay. So g prime of y, that's going to be the derivative of this. G of y is, okay, the square root of y is the same as y to the 1/2, and then of course minus 5y. So the derivative of this will be 1/2 y to the negative 1/2 minus 5. G prime of y squared will be 1/2 I guess I could write it this way, maybe 1/2 root y minus 5. Okay, so g prime squared is going to be 1/2 root y minus 5 squared. Okay, so what you can do is right there, you can put 1 plus, oh wait, you need a square root. The square root there, a square root sign, 1 plus, and then 1/2 root y minus 5 squared. And it says use technology. So this should give you the correct answer for this part, but you need to use technology for this part, because if you try to integrate this by hand, it's going to be a lot of trouble. Okay, so I'm going to show you how you can do it using technology. There's, and I'll write down the program that we're going to use. There could be other programs that are good to use, but we're going to use an online one called Wolfram Alpha. Okay. And that's going to give us this part here. Okay, so we're just gonna plug this integral in, use Wolfram Alpha to find it. Okay, so let me go ahead. What's going on? Okay, so I'll go ahead and I'll go to my web browser. If I can find it. Oh yeah, okay, there it is right there. So I'll go ahead and go to my web browser, open up another tab, and let me see, I'll type in Wolfram Alpha. So it's www.wolframalpha.com. And you can kind of, this one is set up so you can kind of just ask it, tell it to do stuff. So integrate, if you type in integrate, and it gives you examples, okay? It gives you integrate this from 0 to pi or whatever, okay? If you just go integrate, and then it's, what is it, square root of 1 plus, and then 1/2 square root of what, we'll put x. Well, I'm changing everything to x's because I'm not sure. Oh, also I need to put parentheses around here so that it knows that that's in the denominator too. Minus 5, and that's all squared. Okay, that's what I want to integrate. Now, and then I'm going to put from 1 to 4, okay, because that's the integral. And then I hit enter. And it takes a little while, but it kicks out the answer of, and then it kind of shows what that is. Oh, look, it actually, it integrated it. Oh, interesting. Oh, it's the inverse hyperbolic tangent, which we've never done before. Oh, it's actually able to find the integral. Wow. A lot of times it just can't find the integral. Okay, but anyways, the approximation is 14.31 Okay, before it flipped to this, it was 14.3179. Okay, 14.3179. That's what it was showing a few seconds ago, and then it flipped to this right here. We need 4 decimal places. This is the answer that we need right here, to 4 decimal places though. Okay, so 14.3179 was the answer. So let's go back to the other one. And 14.3179 was the answer that it gave us. Good, that's 4 decimal places. Okay, any questions on that? Okay, great, let's move on. If you have any questions about anything, just let me know. Okay, so number 3, find the exact length of the curve. 36y squared equals x squared minus 4 to the third from 4 to 9, x equals 4 to x equals 9, y greater than or equal to 0. Okay, so what we need to do is solve for y first. So divide everything by 36, that gives us this. And then square roots. Now, when you do the square root, you're going to get plus or minus. So you do square roots, you're going to get plus or minus. However, because of this piece right here, which says y is greater than or equal to 0, that means that that gets eliminated, okay, because of this, y greater than or equal to 0. Okay, so you're just going to have the plus part, and then just take the square root of that. So that's x squared minus 4 to the 3 halves, and then the square root of 36 is 6. So you get that. Okay, now the length is going to be the integral from, it's going from 4 to 9. The square root of 1 plus all of that squared. Okay, so if you square this, you're going to get x squared minus 4 to the third over 36. Okay, so you got that right there. Wait, no. I forgot an important step. Boo. Boo. I hate when I forget stuff. This is like, what am I doing? Okay, so I have to take the derivative, okay? Okay, so take the derivative here. You have a 3 halves coming down. Okay, 3 halves minus 1 is 1 half. So that's just a square, it's just straight up square root. And you'll have a 2x coming out. And then you still have this 6 down here. Okay, now these 2's are going to cancel, and the 3 is going to cancel this to a 2. Okay, so what goes here is going to be, if you square all that, then you're going to get x squared, that's squaring this piece, and then squaring that is just going to give you x squared minus 4, and then squaring this 2 gives you 4. Okay, this looks really bad, but watch what happens. And usually when it tells you to do these kind of things, it sets it up so that nice things happen. So try to look for nice things when you do these. Okay, so if you distribute this x squared, you get x to the 4th over 4. And then you have minus, and then you have x squared times negative 4 over 4. That's minus x squared. So you get that. Okay, now this looks really weird, but check this out. I'm going to rearrange it, put x to the 4th over 4 first, or instead of writing it that way, I'm going to write it as x squared over 2 quantity squared. Maybe you see a little bit better about what happens next. Okay, then you have the middle, then you have this term right here, oops, minus x squared, and then you have this plus 1 on the end. Okay. Does anybody recognize what this is? What's inside the square root? I mean, well, think about it this way. What would it be? What
would it be a
go ahead.
trig substitution?
No. What would be the easiest possible situation? The easiest possible situation to have something under the square root. I mean, which would you rather take the square root of? The square root of 9 or the square root of 2? Which is easier?
Square root of 9.
Yeah, the square root of 9. Okay. So the best possible situation is actually where you have something squared, which is actually what you have. This right here factors, and I kind of give you a little bit of a hint right there, into x squared over 2 minus 1. Okay, so if you multiply this out, you get exactly what's inside here. And then the square and the square root just cancel each other off. Yay. Now you also have to worry about what if this 1 is bigger than, what if this inside here is negative? Like, for example, if x is 0, then this is -1. But when you square it, you get +1. But then when you take the square root, you're not going to get this. You're going to get 1 minus x squared over 2, right? But x is between 4 and 9. When x is between 4 and 9, this is definitely greater than that. So this is going to be positive. So this is what it is right here. Okay, so you didn't, now we go to the next stage, which is to integrate. And let's see, x cubed over 6 minus x, and that's going from 4 to 9. Okay, so plug a 9 in, and you have 9 cubed over 6 minus 9. Subtract, plug a 4 in, that's 4 cubed over 6 minus 4. Okay, I used the calculator, and I got 635 over 6. Okay, so I noticed that a lot of the problems from this section, they play down like this. They go down like this, where it looks really weird because they make it really weird so that these nice things will happen. Okay, pretty much. So look for this kind of thing right here, and when you're doing this section, look for this. Okay, let's go ahead and go on to number 4. And number 4 is another common trick that happens quite a bit. Okay, here it's going to be in the y's. So we're looking for g prime of y, which is the derivative of this. You can also think of this as being y to the 4th over 8 plus 1/4 y to the -2. That makes it easier to differentiate. Okay, so now take the derivative. You're going to have a 4 come down, and this is going to be, but then the 4 reduces that 8 to a 2. So y cubed over 2. And then here, you have a negative 2 coming down. So, but the negative 2 reduces the 4 to negative 1/2. So you have negative 1/2. Okay, and then reducing this by 1 gives you negative 3. So this is what the derivative is. So you're integrating from 1 to 2, because that's the limits right here, of the square root of 1 plus all of this squared. And I'll go ahead and put I'll put the y to minus 3. I'll put that to the denominator as y to the plus 3. That's squared. Okay, this is another common thing that comes up whenever you have these kind of problems. If I square that, if I square that, I get the first one squared, which is going to be y to the 6th over 4. Okay, plus the product of those two times 2, so it's minus, okay, this times this, the y cubes are going to cancel, and we'll have so it's 1/2 times 1/2, so it's 1/4. And then I have the last plus the last one squared. No, that's times, this middle one's times 2, I'm sorry. So it's plus 1/2. Plus the last one squared. That squared. Maybe it's better if I had written this as just not squaring it out, but just leaving it like that. Okay. Okay, so this is kind of interesting because what happens is you have this 1 minus 1/2, right? So you get this right here. Plus 1/2 plus 1 over 2 y cubed all squared. Okay, and so what does this part become? What is all this right here? And this is kind of interesting because if you look at this piece right here, okay, look at this right here. Okay, what's the difference between this and say what's in the green and what's in the blue?
The
Okay,
positive. The only thing that changes is the positive 1/2.
Yeah, the only difference is that this is minus, that's positive, that's plus, right? Minus, plus. Okay. Now this one is equal to this squared, right? Because expanding all this out, gives me this. Okay. So the blue one is going to be what?
Y cubed over 2 plus 1 over 2 y cubed squared. Would be that.
Yeah, it's just going to be that one. So instead of a minus, it's a plus. And then because y is between 1 and 2, that means y is always positive. Means that's positive, everything's positive. So when you if I take the square root of this, it's just going to be inside. It's just going to be this inside part. Okay, and then so let me rewrite it as y to the -3 again, so just so we can integrate it easier. And maybe I should have just left it as y to the -3. Oh well, throughout the whole thing. So integrating this gives you y to the 4th over 8. Integrating that piece. Integrating this piece gives us minus. Okay, you raise this by 1 power, so that's -2. And so that means it's going to have a 4 here. And now it's going from 1 to 2. Or okay. So the interesting thing is it's interesting if you compare this with the original. That's kind of an interesting comparison because this is y to the 4th over 8. That's y to the 4th over 8 plus 1 over 4y squared. This is minus 1 over 4y squared. So it's just kind of played everything out this way. Okay, that's kind of an interesting way of that things happen when you have this kind of problem. Okay, so let's go ahead and finish it off. So we put a 2 in. That's going to be 2 to the 4th over 8 minus 1 over 4 times 2 squared. Minus, then put 1s in, so that's 1/8 minus 1 over 4. That's putting a 1 here and a 1 there. What is that? 16 over 8 minus 1 over 16 minus 1 over 8 plus 1 over 4. And I did it on my calculator and I got 33 over 16.